Hello, ladies and gentlemen, again, my 8th grade physical science class, Mr. Hescox, coming back to you. We've been talking about chemical bonds, we talked about ionic, we talked about covalent. One of the ones we talked about was polar covalent. So ionic is a transfer causing a positive and negative attraction. A covalent bond is a pair of electrons shared equally between two nonmetals, and a polar covalent bond is an unequal sharing causing a positive and negative in the covalent bond that causes them to stick together. Today we're going to finish it up, talk about some of the properties of the substances, and wrap this up with a review. Your quiz and test are coming soon. One of the bonds we haven't talked much about was called a metallic bond. So we talked about an ionic bond. An ionic bond was a metal and a nonmetal. Covalent bonds are two nonmetals bonded together. Well, two metals bonded together form a metallic bond. They can bond because they allow the electrons to flow back and forth between the metal atoms, and they kind of give it what they call a sea of electrons, an SEAC. And this metallic bond gives metals their cool properties, such as they're great conductors of heat, great conductors of electricity. They have very high melting points. You fry in a frying pan. The only one that doesn't have a high melting point is mercury. Mercury is actually a liquid metal. If you've ever seen the old movie Terminator, the metal's all running around, that was mercury. That metal is very malleable. We can pound it into very thin sheets and use it for things. Aluminum foil, gold foil, we can roll it into different shapes. And metal is ductile. It can be pulled into wires. Make sure you guys are watching these videos because they do. Some other compounds would be ionic compounds. Ionic compounds tend to be solids, like salt. They have a very crystalline structure, and that crystalline structure makes them very brittle, but it also gives them a very, very high boiling point. It's very hard to get salt, true salt, to boil. Now, if you add it to water, you can make the water boil, but that's different. Ionic compounds dissociate in water. That means that they separate. The positives and the negatives will actually move apart because water has positives and negatives. The negative ions tend to attract to the positive hydrogens, and then the positive ions tend to be pulled towards the oxygens that tend to be negative. Your body has lots and lots of types of ions in it. Your muscles and your nerves are all run by different types of electrical charges for your ions. Covalent molecules are literally the opposite of those other ones. Covalent have generally a lower boiling point, so they melt and boil at a lower temperature. They do not dissociate in water, and covalent bonds don't conduct heat and electricity. Think of plastic. Plastic is full of covalent bonds. That's why we have plastic handles on our pots. So the types of bonds can make things look differently, even though they're made out of the same exact material. This is graphite, like you would find in your pencil. This is a diamond. That's a lump of coal. Depending on the arrangement, the number, and the shape of the particles, you can turn carbon from graphite into diamond or coal, depending on the arrangements. And there's another one called fullerene that I'll show you here that they actually use as a type of lubricant in Teflon sprays. This is fullerene. It kind of looks like a soccer ball. But this particle is all carbon. So we're just about done with this chapter. Let's see if you guys can pick out, is the statement about an ionic compound? Is it about a covalent compound or a metal? Remember, these questions can all be test questions at any given time. It forms ions in water. Write these in your note packet, and then we'll come back and go over them here in a minute. So it forms ions in water. It forms a sea of electrons. Has a high boiling point. A high boiling point. has a low melting point, known as a poor conductor. These are easily shaped. These have a crystalline structure. These have low boiling points. All right, well, let's go over the answers to those, and then I'll let you guys get started. So if it forms ions in water, what is it? That's an ionic bond. Forms a sea of electrons. Did you guess it? The sea of electrons is a metallic bond. Has a very high boiling point. This one you could probably have too. This could be metallic because metals have a high boiling point. Probably the best answer, ionic, have a huge, very high boiling. Having a low melting point. Now this one's only one. The low melting point, that one, covalent. These are poor conductors. Poor conductors. So the poor conductors are usually associated with the covalent bonds. Or ionic as long as they're not in water. If you put an ionic substance in water, it conducts electricity really well. Easily shaped. Well, we use these all the time. The easily shaped ones, metallic. Crystalline structure. That one is ionic. Has low boiling points. Covalent. All right, ladies and gentlemen, we are through chapter 6. If you have any questions, email me, shoot me a message on Remind. Make sure you get your work done in the Google Classroom. Until next time, I'm Mr. Hescox. Be good, be safe. See ya.